Rohan Khera and Mike Gibson coming to you live from AHA 2024. We're talking about the PanEcho study, AI, machine learning, deep learning, really helping facilitate the interpretation of imaging. Talk to us a little bit about what you did.
Uh, Thanks, Mike, for having me here. It's a great honor for our group to be presenting this study at AHA. There has been echocardiography is the cornerstone of cardiovascular diagnostics, and there has been a lot of interest in using it effectively. But the workflow for AI for echocardiography requires, expert acquisition, expert interpretation.
Lots of clicks.
Yeah. Okay. Expert acquisition and expert interpretation. And increasingly, even though we have access to cheaper handheld echocardiographic devices, that presents a bottleneck for us to actually get the diagnostics at scale. So and people have suggested AI as a strategy to interpret echocardiographic videos, but it's always been done for single tasks: detect EF, detect aortic stenosis, including work from our group. It doesn't really translate to an automated solution that we can deploy in low resource settings or even in hospitals in here, where it can be triaging and creating a full report and we can just overread like we would do for a trainee. And so this is PanEcho, where we built a lightweight model that is deployable world over, and we extract 39 diagnostic labels that are routinely captured in echocardiography, taking a full echocardiographic video, all views, all Dopplers, and interpreting them using deep learning to generate these results. And we're excited with the great performance we get both in our data and also external data where we tested the model.
Can I ask you something? Was this, Rohan, was this really true deep learning? A lot of algorithms out there use automated edge detection. They're adapting technologies from the 90s. Is this true black box AI?
It is. We used an image encoder using a convolutional neural network to turn the video frames. And then we actually used a transformer model, which is a new kind of model that ChatGPT uses. And then use that model to stitch the frames together and learn from each frame to frame, all broken down. And then learn on top of that all these separate asks and applications. None of this was done with edge detection. And the point, Mike, is really in real world settings, we don't have perfect views, perfect videos.
Right.
And the ability to do this with deep learning is that we will adapt to those variations that exist in.
Right. Well, that's why I pointed it out, because there's a lot of companies out there using edge detection, but not really AI. This is true AI.
Yes, yeah, and again, it demonstrates its performance by being applied to lower quality acquisitions, to acquisitions in public resources and repositories, and actually beating benchmarks wherever they are publicly reported.
Hmm. And what did you tell us what you found?
So we found that the model is, with deep learning models, all we have are performance metrics. So we were
Hmm.
able to use a full, all studies, including Patterson long axis, short axis. The study is taken in its whole, views are classified, and we can, for 21 estimation tasks where like LVOT diameter, EF, the end diastolic diameter, we have mean absolute errors, which are extremely small compared with the measurement errors that are present in these measures themselves. And we do this for 21 tasks, and where the median mean absolute, a normalized mean absolute error is only 0.13. For tasks that are classification based, where we actually are using information from these echocardiograms for detecting a positive or a negative signature, our model had a performance, a median AUROC of 0.91 across a range of estimation and classification tasks.
Amazing. So, and then in terms of practicalities, does this help you save time in throughput?
I think it just automates the entire process. Since under a couple of minutes you have a full estimation of an single echocardiographic study. Everything is a tabular data element, so it's not just a report that somebody has to manually parse through. You get a tabular output for every single element, and somebody can manually cross-check each, update these numbers. So from a workflow perspective, this is really well aligned with how we read echo studies. We see the images, we update a tabular element, and that turns it into a report, and that we're able to do fully end to end. So from an efficiency perspective, it helps to triage which echoes to be overread first. It helps to really do the normal echoes really quickly, and somebody could just read them later and get them through the system. And then I think we have shown that even if you had like 5 views, like Parashon long and the apical views, you are still able to get very good estimation, suggesting without Dopplers, able to translate it to handheld echocardiography where very few images are captured, suggesting we can do a lot more.
So it'd be great, if a provisional report was put right into the chart after this,
Yes, exactly.
straight from the echo
Absolutely.
machine, and then it gets an overread. That's kind of what we see more and more of. And do you know how this would compare if you compared it to, or have you compared it to those algorithms that use edge detection, automated edge detection?
So some of the models are in public domain, and we have tried to compare them. We are models able to, for those that do EF assessment using edge detection, we're able to beat the performance of those models on detecting those elements. Also for LV, other LV diameter measurements, we are able to beat them successfully. Again, really just showing that our models are able to capture whatever these edge detection models do and do it better.
Right. Unbelievable. I knew this is where we would get. I was always a little skeptical of all the people claiming they were using AI when they're really just using repurposed edge detection from the 90s. This is really an advance. Thanks for sharing with us today. I'd like to get back together after AHA, maybe do a full segment where you can demonstrate this to us, some videos and things. Would that be okay?
Absolutely. That would be perfect.
Great.
Thanks. Looking forward to it.
Thanks for joining us, and thanks to all of you for joining us here live from AHA 2024.